Okay, guys. In the yesterday's session, it was a kind of a demo. So we had some kind of a discussion about what are the topics we are going to cover throughout the session and all. We haven't covered any technical things. Before getting into the actual Amazon Web Services cloud, first we must understand what exactly the cloud is, what are the different deployment models, different types of clouds, advantages, and why everybody is moving into the cloud. These are the basic things we must cover before getting into the AWS. And in the today's session, we are going to cover the basics of the cloud compute. Can you guys guess what might be the cloud computing is? I mean, based on some basic overview, I think everybody might know what is the cloud computing, right? What is a cloud computing? First of all, what is the cloud? How can we define a cloud? I don't need any technical definitions or something, just a kind of a descriptive answer I need, just in your own words or something. Whenever you are trying to learn something, don't chase the technical definitions. Try to interpret the same in your own language, I mean, in your own words, with respect to whatever you can see in the real world. So I can say, I mean, before getting into the technical definition, I can say cloud computing or cloud is something like someone else computer. Like let us say if you recently moved to some a different location, like you are actually from Bangalore or somewhere, and you move to Hyderabad. Generally, what we need, generally you need a house to stay, right? The cloud is alike. Instead of purchasing a house, you are going to rent a house. Let us say if your requirement is for like 1 month or a 5 months or a 1 year, just you will stay and you will pay rent on a monthly basis instead of spending a huge amount of money to buy a house. The same thing, the same way we can understand the cloud also. Coming to the technical definition, we can say it is a delivery model. It is a delivery model means they are going to deliver something. What exactly that something is? Computing services. What are the computing services? Let us say the server, right? Or a database, storage service, or a networking services, or some kind of a web applications, load balancers. These all are services which are delivered or available over the internet. What does that mean? They will maintain the infrastructure, whatever we need, somewhere across the globe, and we are going to get those resources with the help of the internet. Like by sitting at my home, I can utilize the resources provided by the cloud provider. So these resources, I mean, always the cloud, they will deliver the resources like the compute power. Compute power is nothing but like a kind of a CPU, RAM, and so on. Databases, like MySQL, Microsoft SQL, PostgreSQL, MariaDB, DynamoDB, all these databases will be delivered or offered by these cloud. Storage services, S3, EFS, EBS, right? Or something like what we call that, FSX. All these types of storage applications and all other resources will be delivered based on demand. What is the meaning of a on demand? What is the meaning of a on demand? Let us say I need one server. I need one server for my requirement with a 4 CPU, 16 GB of a RAM, and let us say 500 GB of a storage hard disk. And my requirement is I need this particular server on 11th September 2025, and I need this server until let us say 19 September 2025. So my demand or my requirement is from 11 to 19th, so that the cloud will offer you this particular server with these resources from 11 September to 19 September, and they will only charge pay as you go. Means 11th to 19th, how many days? It's like 8 days per day, 24 hours. How many hours we have? 192 hours, right? Is that correct? Okay, whatever. So how many hours you are using the resources, you will be charged for those many hours only. They don't charge you for the entire month, or let us say per day, you are only running that server for 8 hours and then you are stopping it. Then what happens? On a basis of like 8 hours per day, for the total of 8 days, you will be charged for 64 hours only, 64 hours of the usage. That is what the pay as you go model. Some people call the same model as pay as you use. Both are same, just the terminology is different. Pay as you go or pay as you use. Whatever you are going to use or you have utilized, you will be charged for that much usage only. And for in this example, I have used or I have run the server for 64 hours. During the 64 hours, how many resources I have used or I have utilized? Just a 4 CPU, 16 GB of a RAM. Let us say if you have created a server with 8 CPU, 32 GB of a RAM, then you will be charged according to these resources. And I will be charged according to my resources. So it is completely pay as you go. Whatever you are going to use, and you will be charged for that, that many resources only. That is the main advantage of the cloud. And then whoever is going to offer you these cloud resources, we will call them as a cloud provider. If I ask you, could you please mention few cloud provider names? I guess everybody might aware of these three cloud providers because these are a popular and widely used cloud services. Amazon Web Services, Microsoft Azure, and Google Cloud. But apart from that, we have n number of cloud providers available. AliEn, which is a Chinese cloud. Like I think you might heard about Alibaba, right? This AliEn belongs to the same Alibaba group. And then Oracle have their own, they have the cloud. IBM is a cloud provider, Rackspace, GoDaddy, and there are n number of cloud providers. But if you see these two, Rackspace and GoDaddy, you can't compare these two with the first three cloud providers because the way how they operate, the way how the Rackspace and GoDaddy operates are completely different. But these two are also a cloud providers. But there is nothing much that we can manage in the Rackspace and GoDaddy. Just if you need a server, you need to create a request so that the GoDaddy technical team will create the server for you and they will manage everything in the backend. There is no self-service kind of a thing. Obviously, that cost you more. But very small players like small companies, startups, they might prefer these two for shared hosting, sharing the resources with some other clients or some other customers. They prefer this GoDaddy, especially. The Rackspace also a kind of a cloud provider. Many of the companies are using, they're still using the Rackspace also. But here we are going to learn one of these three. Okay, at this point of time, okay, so you said like these are the three major cloud providers. So do I need to learn all the three? Let us say you went for a company, like you have given an interview for a company called ABC. There is no guarantee that they are going to use AWS. They might use Azure or a GCP or AWS. But the thing is, if you learn any one cloud provider, let us say AWS, the concepts are going to be the same on the other two cloud providers also. But the terminology might be different, but the concept is going to be the same. Let me give a simple example. Let us say here on AWS, we have a service called EC2, by using which we can create a server in the cloud. We call it as a virtual server. But technically the name is EC2 instance. With the help of a service called EC2, we will get EC2 instance. The same thing is available on Microsoft Azure as virtual machine. The terminology is different, but the use case, the concept is going to be the same. In the GCP, Google Cloud Platform, the same thing is available as a compute engine. It is called a compute engine. The terminology is different. The naming conventions are going to be the different, but the concept is going to be the same. So if you are able to handle any one cloud provider, easily you can manage the other clouds also. Now, coming to these cloud, what are the major characteristics of cloud computing? Whenever we say something, right, we need to identify what are the characteristics of this so and so cloud. Let us say if you go for some kind of experiment, right? So first what we do, whatever you're going to achieve, what are the characteristics of so and so particle or so and so item, right? The same way, what are their goals? What exactly they're going to offer you? The first thing is on-demand self-services. On-demand self-services. What does that mean? Let us take the simple example to understand these technical terms. I need one server. Let us say I'm located in Hyderabad. I based out of Hyderabad and my office is also in Hyderabad. I don't have any branch offices or something. So I need one server for a kind of a testing purpose with 2 CPU and a 4 GB of a RAM, in which I need 100 GB of a hard disk, 100 GB of a hard disk, and I need a Windows operating system. Windows or Linux, whatever it is, but my requirement is Windows operating system. So this is for a testing purpose. I want to test some application for a shorter period. Let us say I need this server for 10 days only because my project is going to last for 10 days. After 10 days, I don't need this particular server. I don't need this server after 10 days. So here, the main characteristic of the cloud computing is on demand. Means what is your requirement? 10 days. So whenever you demand a service, then only they will offer you. They don't create in advance and they don't charge you for unnecessary things. And self-service. What is the meaning of a self-service is whenever you need this, no need to create a ticket or no need to create a request and no need to wait for someone from the cloud provider need to create your server. What we have to do, we need to log in to the cloud provider's console. Let us say AWS console in our case. Just you are going to that particular specific service called EC2 in this case, and I will choose, okay, I need 2 CPU, 4 GB of a RAM, 100 GB of a hard disk. I need Windows Server, let us say 2019 data center edition, and I need this server to be placed in India, let us say in Mumbai or Hyderabad, whatever the region you prefer. Just you need to select all the options and just you need to click launch. Within 5 minutes, the server will be ready for your usage. That is what the self-service. No need to wait for someone, no need to approve or no need to create for you and all. Just whenever you need, you can log in, you can create it, and you can delete it once you're done with your work. And broad network access. The second point is broad network access. What does that mean? Let us say I created this server in Hyderabad. I'm doing something called user acceptance test. So I hired a few testing team, let us say in US, in United States. What if I ask them to travel to Hyderabad to test this particular application, which is running in a server, which is located in the Hyderabad location? Which is not possible, right? I mean, which is not possible in the sense which involves a huge amount of money for traveling, staying, and all. And here, this cloud offers you the broad network access, which means as per our requirement, whatever the services we create in the cloud, we can make those services are accessible from anywhere across the globe. Let us say I have a different requirement that I don't want anybody to access my server from anywhere across the globe, except from my office location for high security reasons. That is also possible. But if you need that service to be accessible from anywhere across the globe, that is possible with the help of a cloud computing. Simple thing. Let us say if I am running a website on this particular server, example, gmail.com. Google never asks you to visit their office to access your emails and all, right? They allow you to access the gmail.com website from anywhere across the globe. How that is possible? There is something called a public IP, which we will cover in the next coming sessions. There is a public IP, private IP, right? With the help of a public IP, we can access the resources from anywhere across the globe. And here, the third characteristic, which is the most important one, location independent resource pooling. Location independent resource pooling. What does that mean is, already I said, I am from Hyderabad and my office is also located in Hyderabad. Now I got a new project from a client. The client belongs to, let us say, London, which is European country. So everything is finalized and the project is approved, and I have my team should start working on that particular project, setting it up, configure, monitor, manage, and all the things. And this client has a requirement that their data must exist within the European countries only. They do have something called GDPR laws and all. They don't want to allow their data to be placed outside of the European countries. So what if there is no cloud? What if there is no cloud? Whenever I purchase a server, that server has to be placed in my office, which is Hyderabad, which is out of the European countries. Then the client will not accept the project and the project will never execute, right? Here, what is the option? I need to hire a place in the London, like a branch office for my company, and I need to set up a data center here, and then I need to set up everything here, which involves a huge amount of money. But with the help of the cloud, by sitting in Hyderabad, I can spin up, I can create my server in any location. It can be in the London, it can be Singapore, it can be in the Frankfurt, wherever Amazon is maintaining the data centers. By sitting in Hyderabad, I can create my server. I can place my server in any of that particular location. That is what location independent resource pooling. Irrespective of your physical location, you can pool the resources. You can get the resources anywhere across the globe. And the next characteristic is rapid elasticity. Just let us go with the same old example. I think wherever you go, everybody will take the same kind of an example. So I'm running an online store. Okay, this is my server in which I'm running my Amazon.com online store. So this server is having 2 CPU and 4 GB of a RAM and 100 GB of a hard disk. 100 GB of a hard disk. So what happens? It can handle up to 100 users at a time. It can handle up to 100 users at a time. But what if I know that I have some reports that from day after tomorrow, my server might get 300 users at a time? Means I need to increase the resources by 3 times. I need to increase the resources by 3 times, which is possible with the help of the cloud. If there is no cloud, what we have to do? You need to purchase the physical servers again. You need to procure the items. You need to install it, and then you need to start the server. But what if this load is only for 2 days? After 2 days, whatever the new hardware you have purchased, that has to be kept idle, waste of money. But in the cloud, rapid elasticity. What is the elasticity? You can expand and you can shrink as per the requirement. Whenever you need more resources, you can get more resources instantly, and you can reduce the unnecessary resources instantly with the help of a rapid elasticity. You can configure that a manual increase, or you can configure automatically also using a concept called auto scale, using a concept called auto scaling. Already I mentioned they will calculate the charges and everything as per your usage. Pay as you go or pay as you use. That is what measured pay per use service. If you go for AWS or if you go for Azure or Google Cloud, these are the major essential characteristics that they are going to maintain while offering the cloud services. First one is a on-demand self-service. Whenever I need a server, I can get the server from the cloud. And whenever I don't need that server anymore, I can get rid of that server and I can save the money. And whatever the server I created, that server can be accessible from anywhere across the globe. And by sitting in one geographical location, I can maintain or I can run my services anywhere across the globe. Example, by sitting in India, I can maintain my servers in the US, UK, or anywhere across the globe. Rapid elasticity means depending on your requirement, you can increase the resources instantly, or you can reduce the resources immediately to avoid unnecessary charges. So here, let me take this rapid elasticity and let me go with one more example to understand why the cloud is more beneficial than on premises. Just to understand the advantage with a simple example. Let us say, assume that you are working for a company in which there are multiple projects running, multiple employees are there, and all the servers. You have a data center, in which the servers are maintained, and that data center is on premise, means the data center is not in the cloud and that is in your office. All the servers are occupied with different projects and there is no spare resources available. One fine day, your company got a new project, but a small project, but your company can make good profits from that. That only lasts for 30 days. The project is only for 30 days, but they're going to pay a huge amount for that particular project testing. But the condition is that project must start within the next 2 days. If you are the data center administrator, how can you handle this situation? You don't have any additional resources to spin up a new servers to accommodate the new project, because let us say the new project requires minimum 5 servers to complete within 5 days. What you have to do, you need to procure the servers from the market. Here there are two challenges. One is you can't buy a server like just by going to a shop, and you can't buy like your laptops or desktops. First you need to raise an first, okay, as per the company's policies, first you need to get the quotations from minimum 2 to 3 different vendors, and whoever is giving you the quotation for the lowest amount, you need to raise a purchase order. Then the purchase order will be accepted and that will be sent to the warehouse, and the server will be assembled and or built, and then they will be delivered. It will take minimum 30 to 45 days of time. To get a server, you need to wait minimum 30 to 45 days of time. It's not like a normal laptop which you can buy directly going to a shop or what we call that, the service center or somewhere. But the project deadline itself is a 30 days that has to be completed. That's the first challenge. The second challenge is you need to invest, like let us say a small server might cost you 5 lakhs Indian rupees. So total you have to spend a 25 lakhs only for 30 days. After 30 days, these servers are not required. You need to keep them idle aside. You are wasting money, right? But in the cloud, without purchasing the servers, no need to wait for 30 days or 45 days. Instantly, within 5 minutes, within 5 minutes, you can create as many servers as you can. Depending on, let us say I need like 20 servers, I can create the 20 servers within less than 5 minutes. If all 20 servers are required with the same resources, I can select the resources like 2 CPU, 8 GB RAM, 100 GB hard disk, number of servers 20, and I can click on launch. If there are different configurations, each server you need to create differently, but each server will not take like a, it will never take like more than 5 minutes to make that server usable. That is the main advantages of the cloud computing. One is rapid elasticity, on demand, and no need of initial investment. In the previous case, if there is no cloud, you need to spend 25 lakhs of rupees, right? You need to spend 25 lakhs of rupees just to get the server for just 30 days. But with the help of a cloud, no need to spend that much money. Just you need to pay a few thousands per month per server, and you can complete your project, and you can get more profits from by reducing operational costs. Okay, now what are the cloud deployment models? What are the different deployment models? The way how the cloud is getting created, the cloud data center or the cloud environment is getting created. There are four types: public cloud, private cloud, hybrid cloud, and community cloud. What exactly these cloud deployment models, how they operate, and what are the use cases of each type of cloud deployment mode? I guess many of you guys might understand the purpose or the use case of a cloud deployment models based on the name. Okay, first thing, let us say the public cloud. Without reading the description, can you guess what might be the public cloud is? Public means everyone, right? So the public cloud is for anyone. Means you can create your servers in the public cloud. I can create my servers in the public cloud. Someone might create their servers or the resources in the public cloud, like AWS, Azure, Google Cloud. These all are public clouds, examples for the public clouds, open to everyone. That doesn't mean my data is visible to you and I can that doesn't mean I can't see your data also. The data confidentiality, security, and everything will be there. But the thing is that public cloud can be used by anyone to create and run their resources, like public transportation, right? RTC buses. Anybody can use it, but that doesn't mean I am the owner of that bus or something. If I want to travel, right, just I can board a bus, RTC bus, and I can travel wherever I want by paying the money. The same way, public cloud. The private cloud is like your personal vehicle, your personal car. What is the meaning of that? Only you can use it, or whoever you authorize, they can use your private car. Some anonymous person or someone from your city or somewhere else can't use your private car, right? Your personal car. The same way, the private cloud is the cloud which is built for individual organizations or a single organization. We can say the private cloud is nothing but the on-premise data center. The data center which is maintained in your organization, I can say that is a private cloud. Why should we say cloud? Because in my on-premise data center, sometimes I can run the servers for my clients, and my client will pay me for maintaining their servers in my organization's data center. The private cloud is exclusively for a single organization. In my company's data center, nobody else can maintain their servers. That is the private cloud. Then what is this hybrid cloud? Just try to guess. Later I will explain what is a hybrid cloud. Generally, what is the meaning of a hybrid? What is the meaning of a hybrid? Hybrid is something like combination of multiple things, right? Exactly. The hybrid cloud is the combination of public and private cloud. What does that mean by? What does that mean by? Let us say here I have a data center in the AWS, like I can say AWS. So here some application is running, and here in my office I have a data center like office. Here I have some what we call that some servers are running, let us say some databases, some applications for internal things. But for security reasons or for data integrity, what we do is every day we will create a backups in my office. And there is a concept called offsite backups. What does that mean is the backups to be stored in a different location. The reason is, let us say you have very important pictures, let us say your marriage, your wedding anniversary pictures or your wedding pictures or something. You have like 5 different copies. Each image you have created as a 5 copies, and you have stored all the 5 copies in the same laptop. What is the problem? If your laptop got corrupted, you will lose all the backups also, right? What if an organization maintains all the backups in the same building? If there is an earthquake or if there is a flood or a fire accident, actual servers will be lost, data lost, and backups also lost. You can't recover the data. So they follow something called offsite backups, which means they will upload to the cloud, like OneDrive. There are a number of things. For that purpose, I mean, hybrid cloud is not only for this use case. This is one of thousands of use cases. So what I do for a secure data transfer, I will connect AWS cloud and my on-premise data center cloud using a VPN service, so that whatever the data is getting transmitted will be transferred using a secure channel. We call it as a IPsec tunnel and all, which are related to VPN things. So here, this combination is called as hybrid cloud. If you connect the public cloud and private cloud, whatever the use case might be, and we call that as a hybrid cloud. So we got all the 3 types, right? Public cloud, private cloud, and hybrid cloud. Now, what is this community cloud? What is this community cloud? Okay, based on the name, you might say, okay, this cloud is built for a specific community. That's correct. But what does that community stands for? What does that community stands for? It's not about a religion or something, religion or a geographical location. It's not about that. Generally, if you're staying in a like a apartment, right? You can call that the 20 families as a community or something. But this is not such kind of a community. Can you guess what might be the community? Okay, this is the cloud designed for a specific kind of organizations. Let us say, if you go for some kind of finance institutions like banks, it can be a private banks or non-banking sectors, whatever it is, they do follow some kind of some set of rules and all. So here, the community cloud is designed for a specific kind of businesses, means only the organizations which are into that business line can use this cloud. So I will give a simple example. In the AWS, we have a kind of a community cloud. That is, the name of that is this one, US-GOV. We call it as US Gov Cloud. What does that mean? Only the United States government institutions can use that particular cloud. Likewise, there is a separate cloud for China. Only from China they can use such clouds. For a community, in this case, US government organizations or US government institutions are one community, and that cloud is only for such community organizations. Only they can create their servers in that community cloud. But being an employee working for a public companies or private companies, obviously we go with public cloud, private cloud, and hybrid cloud. Unless you are working for some US government, you won't get a chance to work on this community cloud. These are the four deployment models. Whatever the cloud deployment model you consider, the concepts are going to be the same, which means the types of the clouds. In every cloud, they offer hundreds and hundreds, thousands of services, right? If you say AWS, there are like 250 plus different services available. Those services are categorized into different types of clouds. They're categorized into different types of clouds. If you see from the bottom side, if you see from bottom side, infrastructure, IaaS, infrastructure as a service. ST stands for storage as a service, means they offer you storage as a service. P, platform as a service. D, database, function, software. What exactly these types of clouds are? Let us try to understand. To understand this better, first, I would like to give you some example. Let us say my developer designed a PHP website in which my company's information is available. And they asked me to host that particular website, to host that particular website. Then what I will do, then what I will do. So first I will get a server. Okay, let me try to explain in a different way, in the easiest way. So first you need to get a server, right? First you need to get a server in which you will have some CPU, some RAM, and on top of that, you will have something called a storage, which is a hard disk. Networking, power supply, these all are the hardware part. Then what happens on top of the storage? What we do is we install something called virtualization. What is a virtualization? Virtualization is used to create multiple virtual servers on a single physical server. Means, let us say if you need 10 different servers, instead of maintaining 10 different physical boxes, we will purchase a single big physical server. With the help of a virtualization, we have to create multiple virtual servers as per the requirement. On top of the virtualization, we will have our servers. Then you will have an operating system. Without an operating system, you can't use any server. Then on top of the operating system, there's a OS, right? You need to install something called a web server. You need to install something called a web server. Web server is to host the websites. Web server plus a database if it requires a database. Then you need to configure that application configuration, right? Without a configuration, there is nothing, right? Then on top of that, you need to place the data. Data is nothing but the code. These are the different layers available in your server whenever you are running some small application also. So here is the hardware part. This is a virtualization layer. This is an operating system and the softwares, two softwares. One is a web server software and the database software. And sometimes there might be some dependencies also, middle layer, like Java runtime environment, if it is Java application. And if it's a .NET application, there might be something called .NET framework. Different things are there. So in these layers, depending on what type of cloud it is. So here, IaaS, infrastructure as a service, means they are going to offer you the infrastructure, Infrastructure means the hardware part, CPU, RAM, storage, and the virtualization technology. They will offer you that, and they will manage this entire infrastructure for you. Then what is your responsibility? Operating system maintenance. I mean, once the system is ready, let us say the example EC2 instance. You will choose, I need 2 CPU, 4 GB RAM, 100 GB hard disk, and Windows operating system. A server will be created, and we will never worry about the hardware part, CPU, RAM, storage, virtualization. That will be taken care by the cloud provider. But what is our responsibility? Operating system maintenance, regular Windows updates, hardening the operating system, installing the applications, managing the applications, making sure that the applications are up and running like 24 by 7, configuration part, data, regular backups of your code modifications, and everything is your responsibility. So here depends on the type of the cloud, the responsibilities are going to be shared between you and cloud provider. If you see the infrastructure as a service, they are going to offer you the infrastructure. In the next slide, I will explain what is our responsibility and what is cloud's responsibility in infrastructure, platform, and software as a service. Okay, ST, storage as a service. Like best example is a Google Drive, right? Just what is who is responsible to make that Google Drive is up and running? I am not responsible and you are not responsible, right? Google will maintain, they will offer you the storage. Just I am responsible to upload or download, making sure that whatever the data I uploaded, that is going to be a public or private as per my requirement. Data security, data backups, data copies, that is my responsibility. Platform as a service. So in this example, what is the platform? This entire thing is the platform. On this platform, my PHP website is going to run. In the platform as a service, what the cloud providers will do, they will offer you a platform and they will maintain the entire platform. What is our responsibility? The data. So in the AWS, we have a service called Elastic Beanstalk. Elastic Beanstalk, in which just you have to upload your PHP code and the PHP website will be up and running. If you have a Java, you can upload it. If you have a .NET, you can upload the .NET code and your application will be up and running. You are not responsible for the platform to be up and running, or it is going to be the high availability. And in the DAAS, database as a service, generally, if you need a database in your laptop, what you have to do, you need to download the database software, you need to install it, you need to configure, then you need to create the database, right? But here, the cloud provider offers you the database as a service, means no need to install, no need to configure, no need to update it regularly. Just create your database and use it. We have something called RDS on Amazon Web Services, relational database service, in which they are going to offer you 6 different types of database engines. And all those 6 are popular, like MySQL, Microsoft SQL, PostgreSQL, MariaDB, Oracle, right? They are the popular databases available. FAS means function as a service. I mean, generally the developers will use it, or sometimes DevOps people also use that function as a service. What does that mean? So to execute something, the developers will write a function, and to run the function, you need something called function. Let us say if that is a Python code. To run the Python function, the server must have the Python runtime environments. If it is a Java, it must have a Tomcat kind of a thing. So without worrying about that runtime environments, to run the functions, Amazon is offering you the function as a service. Means simply get the code from the developer, create that code as a function as a service. In AWS, we have something called Lambda. Just create that code using the Lambda function without worrying about creating a server to run the functions. You can run those functions using the Lambda functionalities. Software as a service. The best example is the one which we are using, the GoTo meeting. Slack, right? Or earlier we used to have a Skype, Microsoft Teams, these are Gmail. These are the examples for the software as a service. Means just we use it. Someone will install it, someone will maintain it, and we are nothing. We are not responsible for nothing. Simply, we are responsible for nothing. If you compare the on-premise, this is infrastructure as a service, this is platform as a service, and this is a software as a service. Here, if you maintain the same PHP application in your office on premises, then everything is your responsibility to maintain, manage, and to make that application highly available. Starting from the networking like internet, storage, hard disks, physical servers, virtualization, operating system, middleware, runtime, data, applications. Everything is your responsibility if you are maintaining a server in your office. In the infrastructure as a service, this infrastructure is managed by cloud. Whatever you can see in the reddish, orangish, red color, that is managed by AWS, I mean the cloud provider. Networking will be managed by cloud provider, storage disks, CPU, RAM, virtualization. That will be managed by cloud provider, and we are responsible for operating system maintenance like monthly maintenance, monthly patching, securing the operating system by enabling the firewalls, not allowing all traffic kind of a thing, middleware, runtime environments like Java, .NET, JRE, .NET frameworks and all, data, your code, application, web servers. That is your responsibility. In the platform as a service, everything is managed by cloud except the data and the applications. Data in the sense backups, backup of your code, free regular daily backups and all. And the application is the code which is developed by the developer, because cloud can't develop your code, right? They don't know what is your requirement and all. Backups, you need to enable it, and the backups will be taken care by the cloud provider again. And in the case of software as a service, everything will be taken care by the cloud provider. The best example is Gmail. Gmail means we will never ever worry about your emails available in the Google's mail server. If something went wrong in the backend, Google themselves revert or recover all the all the data which we have lost in the case of worst thing happened. That is what the software as a service. But majority of the time in the AWS, we use infrastructures as a service, platform as a service, database as a service, and a function as a service, because we have a service called a Lambda. We will cover all types of cloud services. Okay, so these are the basics of the cloud computing, the kind of introduction and all. And if you see the advantages, I think already we have covered everything. Advantages, see here, what we call that the low maintenance cost, because everything will be managed and maintained by cloud provider. Mobility, you can move your servers from Hyderabad to Mumbai or Hyderabad to US or UK. Services are available based on pay per use, pay as you go, pay as you use, whatever. Unlimited storage capacity, no need to worry about my hard disks will run out of disk space. Immediately you can increase with just few clicks. Data security, they maintains like industry level firewalls, security mechanisms like encryptions and all. Backup and restoration, just we need to enable the backups, and the backup process will be taken care by the cloud providers. Excellent accessibility, like from anywhere you can access these cloud resources. And apart from that, there is something called initial, or we can say, sorry, total cost of ownership. To get a server in the cloud, the total cost of ownership is almost negligible. But to get the same server in your office, you need to spend a minimum 5 lakhs rupees, like to purchase it and to get it to your office. total cost of ownership is almost negligible in the case of cloud computing. Okay, right. So these are the cloud computing basics in which we covered essential characteristics of the cloud computing. We have seen the different deployment models. We have seen what we call that different types of a clouds, right? We have seen the different types of a clouds and all. So now, are you guys clear or any questions on this particular cloud computing thing? If you have any questions, just feel free to use the uh, chat box in the meeting, or you can click on raise your hand so that you can allow and you can ask me the questions. Yes. Okay, so if you have any question, just you can raise your hand so that I will allow you to unmute, or you can use the chat box, or you can use the messages to send your questions. Anybody having any questions? At least, do you guys got some idea about what exactly the cloud computing and how it is useful and all? Okay, so I see thumbs up symbol, which means you guys are clear and no confusion or no questions. Okay, so if you guys are clear, you guys can leave for the day. In the tomorrow session, we will start with AWS. What exactly the AWS is offering and how they are maintaining the global infrastructure across the globe, and the terminologies like regions, availability zones, edge locations. These are the things which we are going to cover in the tomorrow session. And what are the things we are going to cover from tomorrow? They are most important for the upcoming sessions, because these are the kind of a basic things to understand the entire AWS cloud. Okay, right. So I hope everybody got cleared with the cloud computing thing. And if you have any questions, just feel free to ask the questions. Yes, Harsha, you can unmute and you can ask the question.
Sir, you mentioned mobility. My question is, at a time we can use multiple location at a time. While
I
for
mean, like,
suppose
what exactly the
right,
requirement?
for suppose I want to use Hyderabad and Singapore. We are having services in Hyderabad and Singapore and USA. I want to use
Yes,
multiple times. At a time, I have to use the services. Can we
yes, you
use
can
that one?
use. Yes, you can use. That is the actual requirement. So
Okay.
whenever you create a cloud account, there is no
Hmm.
restriction that you have to use a single region, single location.
Okay.
In the real time, if you use the cloud to create your servers across the globe, because if I have a United States client, I need to maintain their servers in the US. If I have like something like a European client, I need to maintain their servers in the European geographical location. And sometimes I have to maintain my servers in Canada or in India, right? So you can use all the regions as per your requirement. There is no restriction, there is no limitation or something.
Oh, thank you, sir.
Yeah. Uh, Anybody else have any questions? Did we get notes of every session? Yeah, I will share that. No need to worry. But uh, I recommend you to write down the points on your own also, because that will be useful for you to like whenever you see your handwritten notes or something, easily you can understand. But the class notes I can provide you. No need to worry about that. Okay, so next one, wait a second. Yeah. Dattatreya, you can unmute and you can ask the question.
Uh, Good evening, sir. My name is
Yeah,
Dattatreya.
good evening. Yes, hi. Good evening.
Sir, can you please again explain what is software as service and
Okay,
fast
software
fast?
as a service means, yeah, software as a service means everything will be maintained by the provider only. We
Oh,
are not responsible for anything. We are not responsible for anything. For that, I have given an example of Gmail. What we
yes.
use, just we will log in and we will use it. We will never worry about whether the backend mail servers are running or not. What if the mail servers got crashed and all? Because everything will be managed by cloud provider itself. Just we log in and we use it. And the
Oh,
other examples, the Teams application or a Skype. Earlier we have a Skype and the GoToMeeting which we are using. I need to
yes.
install the software and I have to use it. I'm not maintaining or I'm not managing. For using that, I'm going to pay some money on a monthly basis. That's it. But I'm not
Oh,
responsible for anything. Everything will be taken care by the cloud provider.
yes, sir. It's clear, sir.
Okay, right. Any other questions? Anybody else? Okay, then it seems everyone is clear. And most probably by tomorrow, just I will create a group also, Telegram group, so that you guys can be a part of that. And whenever you're getting any questions, like while you are doing the practicals or something, just you can share your questions, or if you're stuck with some errors, you can share the screenshot of the practical errors and all, and you can get some guidance from me or some fellow students also. Okay, right. Thank you, everyone. We'll continue tomorrow.